Good morning. This is Robert Moyeda with the National Weather Service in Miami, and this is the 2022-2023 dry season outlook. Slightly delayed this year due to the impacts from Hurricanes Ian and Nicole, but we're glad to be able to do this even if it's a little bit later than normal this year. Once again, I'm here at the South Florida Water Management District. We've been doing it here at their EOC for the last few years. Excuse me, and it's a really nice setup. So I really appreciate the folks here from the South Florida Water Management District to host this event. So once again, as we've done in years past, I'll start out with the weather side. Do a recap of the rainy season, which ended back in October, and then we'll go into the outlook for the dry season, and then I'll be joined by Akin Owosina. He's the Chief of Hydrology and Hydraulics here at the South Florida Water Management District, and he'll be talking about the hydrology or the water side of it. So we will present both sides of the outlook there. And then after that, we will have opportunity for questions and answers. All right, so we'll get started here and put up the slides here in a couple of minutes, or actually momentarily, and then we'll get started with the presentation. All right, so we'll do a quick recap here of the rainy season. Of course, the rainy season is defined starting on May 15th and ends on October 15th. Those are fixed dates that we went with starting in 2018. So rainy season started out pretty wet, especially in the beginning of June. We had potential Tropical Cyclone 1, the system that eventually became Tropical Storm Alex. That brought quite a bit of rainfall to many parts of South Florida, especially along the lower southeast coast, where we had anywhere from 10 to 20 inches of rain common across those areas in the first 2 weeks of June, and really most of the rest of South Florida had about 6 to 10 inches of rain. So we started out with quite a bit of rainfall during the first 4 to 6 weeks of the rainy season. But then once we got into the second half of June, it got quite dry over at least the eastern parts of South Florida and even up into central Florida. We had a persistent subtropical high pressure system that's set up over the western Atlantic, and that it stuck around for really well into August, actually through the month of August. So from the second half of June all the way through the end of August, we had below normal rainfall over all of southeast Florida and even into parts of central Florida, while western parts of South Florida remained near or above normal. So we'll get into a little bit more of the details on that here with some graphics that I'm about to show you. Then when we got to September, we started to get a little bit more widespread or the rainfall coverage was a bit more widespread, including parts of the East Coast. And then, of course, we had Hurricane Ian right at the end of September, and that delivered quite a bit of rainfall to the area. And so anyway, we'll show some of those graphics that really spell out the big difference between where we were in July and August and then where we were after Ian at the end of September and October. Then after Ian departed, we got some dry air that came, that moved into the area in the wake of Ian, and that actually lingered through the middle of October. So really the departure of Ian effectively ended the rainy season pattern. So once Ian departed and the dry air came in behind it, our near daily rainfall that develops over the peninsula during the rainy season pretty much shut off. So these are just some rainfall totals for select locations across South Florida. You can see up there on the top there, we have Hollywood with over 54 inches. Now, a lot of that rainfall fell early in the rainy season, and then it again fell towards the end. So we had the middle part of the rainy season where not much rain fell, with a lot of, again, so the rainfall was skewed at the beginning and at the end of the rainy season for many areas. Now, in areas, for example, like Marco Island, Naples, areas in the western parts of South Florida, rainfall was a bit more evenly distributed throughout the rainy season. So there was quite a bit of variability where you can see, for example, areas such as Hollywood over 54 inches for the entire rainy season. But then you had other areas along the East Coast, for example, like Pompano Beach. They had just a bit over 38 inches. So there was quite a bit of variability, even over very short distances across parts of the area. So this map shows same information, but we're showing it kind of like more of an aerial distribution, so you can get a sense of where the highest rainfall fell. So the green colors are the higher rainfall amounts. So you can see areas in the little bit there to the east of Naples and in the western Collier County. So there were some pockets there that had over 60 inches of rain. So there quite a bit of rain fell, and it was more evenly spread out in western parts of South Florida. But then you can see not too far away, I have a pointer here. You can see here these red and orange, these darker red colors. Those were areas that had less than 40 and in some cases less than 30 inches of rain. So you can see quite a bit of variability. So overall, we ended up a little bit above normal over the interior areas, but we were below normal over parts of Southeast Florida when you talk about the entire rainy season from May to October. So this is another way of showing that. This is a graphic that the South Florida Water Management District puts out, and this is basically from the beginning of June all the way to the middle of October. So at the end of the day, we were a little bit above normal. But again, how the rainfall was distributed was certainly a factor, and we'll be talking more about that as well. So this is the breakdown month by month. So we started out, at least in May, a little bit on the dry side, or maybe closer to normal. But then in June, when we had potential Tropical Cyclone 1. That's when the rainfall totals really began to pick up, especially along the lower southeast coast and even around Lake Okeechobee. Although you notice in Central Florida, they really didn't get too much of the rainfall from potential Tropical Cyclone 1. So that, again, the bulk of the rainfall with the early June system was along the lower southeast coast. But then once we got, again, as I mentioned before, the latter part of June and especially into July, that subtropical high really set in across the area, and it dried out, especially the eastern parts of South Florida and Central Florida. So you can see the yellow colors here depicting pretty large areas of below normal precipitation, except for areas then right along the Gulf Coast where they had a bit more frequent precipitation or more regular precipitation, so to speak. So those areas ended up a little bit above normal. So now shifting into the second half of the wet season, in August you can see the brown areas expanded. So August was the driest month of the wet season, which is pretty unusual. Usually July ends up being the drier of the months of the wet season, but this year it was August. So you can see how dry it was. But then in September, it obviously was much wetter, especially towards the end of the month, of course, with Hurricane Ian being the big influence here. And you notice areas up here in Central Florida really got pretty wet as a result of that storm. And then, as I mentioned before, behind Ian, we had an influx of dry air, and that dry air stuck around for the remainder of what was left of the wet season. So we went back down below normal for the final 2 to 3 weeks of the wet season. All right, so now let's look forward to the dry season. Actually, the dry season's already here. We've been in the dry season for almost 6 weeks now. So I'll just back up a little bit here. So we finished October drier than normal. Then in November, at least now being the last day of November, we could have put a recap of November as well. We actually ended up being a bit wetter than normal in November. We had, of course, Hurricane Nicole, which provided more rainfall across the area. And then we also had a stalled front a couple of weeks ago that added additional rainfall. So parts of southeast Florida had about 5 to 10 inches of rain during the month of November, which is above normal. And the only areas that ended up being dry in November were down in the lower Everglades and in the Big Cypress area, where they've had below normal rainfall. So again, we're after a bit of it's been kind of an up and down the last few months. Dry August, wet September, dry October, and then some areas had a wet November. So that leads us now into the dry season outlook. If you've been following this the previous 2 years, this year is really not much different. We're calling for, again, the Climate Prediction Center is calling for above normal temperatures, or at least a likelihood of above normal temperatures for all of the southeast U.S. and Florida. And you see that the probabilities are of that above normal for temperatures is 40 to 50%. So it's not far from a slam dunk, but certainly we're leaning towards the likelihood of above normal temperatures. And now for precipitation, we're leaning towards below normal rainfall. And again, this is same as it's been the last 2 years, with even higher probabilities of below normal precipitation in central and north Florida. So this pattern of above normal temperatures and below normal precipitation that we've had the last 2 years, that's the outlook again for this coming winter. And what you're seeing here is the December through February outlook, but it's the pattern is very similar for the duration of the dry season, which goes all the way through April. So the factors that we consider when in these outlooks is the state of the ENSO, the El Nino Southern Oscillation. So we have another La Nina expected this winter. So this what we're calling a triple dip. In other words, this is the third consecutive winter of La Nina conditions. And then we also look at long-term climate trends. So what we do, we kind of look at the last 10 or 15 years and see how those last 10 to 15 winters or the last 10 to 15 dry seasons have trended as far as temperatures and rainfall. So that's considered as well. The past 11 winters, actually we've had 11 consecutive winters of warmer than normal temperatures in South Florida. So that's one of the factors that goes into this upcoming winter outlook. And then we also use dynamical and statistical models to help us, to see if these trends and the things and the conditions that we typically see with La Nina are holding, or at least are being reflected in the models. So just really quick, just a little primer, as we always do, on La Nina, which is of course a big factor in the dry season outlook. And La Nina again is part of this oscillation that we call the ENSO, where ENSO standing for El Nino Southern Oscillation. And the counterpart, or the opposite phase of the ENSO, is El Nino. So these phases occur about every 3 to 7 years on average, and they can repeat from one year to the next. So last year we had what we call a double dip. This year we have what's called a triple dip, or third year in a row of La Nina conditions. So these oscillations are naturally occurring, and they result from interactions between the temperatures in the tropical Pacific Ocean, or the sea surface temperatures, and then the atmosphere above. So there's an interaction between the sea surface temperatures and even the below surface temperatures and the atmosphere. So those changes in the ocean temperatures affect tropical rainfall patterns and the winds in the Pacific Ocean, and then those changes in turn impact ocean temperatures and currents, and they also influence and impact weather patterns, not just in the Pacific Ocean, but across really the entire globe. So in order to confirm the presence of either La Nina or El Nino, or in the case of what we have now, to confirm the presence of La Nina, we need to see atmospheric coupling. In other words, we need to confirm or make sure that the conditions that are occurring in the atmosphere are matching those changes in the sea surface temperatures, which again help to influence those changes in the atmospheric patterns. And certainly we are seeing that with not just the La Nina of the past 2 years, but with this current La Nina, which is expected to linger or persist through the winter of 2022-2023. Now, as I mentioned, this is the third consecutive winter of La Nina conditions, and we've only had 2 other periods since 1950 in which we've had 3 La Nina winters in a row. So those were 1973 to 1976, as well as 1998 to 2001. So this is a relatively rare occurrence to have a third consecutive winter of La Nina. Usually when we have a repeating La Nina or El Nino, it's usually like a 2-year event, and then we'll either go to neutral the third year, or sometimes you'll go to the opposite phase during the third year. And here, you can see going back to 1950, again, showing this oscillation. So, those blue colors are the La Nina, and the orange is the warm phase or the El Nino phase. So you can see how it alternates from blue to orange. There are times, there are periods there where it's relatively flat, where we were kind of like in a weak or maybe even neutral patterns for a few years. And then we have other periods like what we've had recently where it's been a bit more variable. This is the third year of La Nina, but before this 3-year La Nina run, we did have a couple of years of El Nino. So it's kind of gone back and forth a bit. So anyway, you can see there, those are the inside those blue circles there, those are periods when we've had extended La Nina episodes. And then the yellows there, these yellow ones in the mid-70s and they're right around 1998 to 2001, those are the periods in which we had 3 years in a row of La Nina winters. So the forecast is for La Nina to linger through at least February. On that graph there, the blue bars are indicating the probability that will be in La Nina. And then the gray bars are neutral, in other words, neither La Nina or El Nino. And then the red is El Nino. So you can see as we get into 2023, especially once we get to the February, March, and April timeframe, the chances of La Nina actually decrease, and the chances of neutral conditions begin to increase. So this is suggesting that this current La Nina that we're in should begin to gradually go away or transition into a neutral pattern during the spring, and then looking farther out in time into next summer, with a high level of uncertainty, of course, you can see where the red El Nino begins to pick up a little bit, or at least the probabilities increase a bit more, but stressing it's still highly uncertain. And at this point right now, if we wanted to look way out in time towards summer of 2023, right now it looks like neutral might be, at least at the beginning of the summer, might be the more likely phase that we'll be in. So how does La Nina influence weather patterns in the winter across the United States? So what the typical pattern is, again, this is not something that happens every single day during the winter during La Nina patterns, but it tends to be the prevailing pattern. We have a variable polar jet stream, which tends to extend from the Gulf of Alaska and then will dip down into the northern or central United States and then go back up towards the northeast U.S. and eastern Canada. So we have a high pressure system that typically sets up over the central Pacific Ocean, and that tends to steer that jet stream more to the north over Alaska or near Alaska, and then down across the northern U.S. and central U.S. So that's the average, I guess, over, if you take an average over like a 2 or 3 month period, that's what we'll probably end up with. So the position of that jet stream does, of course, influence where the storm tracks go, which carry precipitation across from west to east across the continental United States, and it also influences where the cold air masses will come down on the backside of those storm systems. So with the jet stream being farther to the north on average, causing those winter storm tracks to pass well north of Florida, that leads to typically less moisture and instability in association with fronts that do make it into Florida. So if I go back to the previous slide here, you can see this area here across the southern tier of the United States, and Florida is depicted as drier during a typical La Nina, and this is because of the storm tracks being farther to the north, less precipitation for those fronts for less moisture available for those fronts as those fronts move down, therefore, on average, less precipitation. So, and that also results in a tendency towards less storminess. So in other words, these fronts that move into Florida tend to be not just drier, but also not have as many thunderstorms associated with them. That doesn't mean that every front will be like that, but again, that's the average. And also the jet stream being farther to the north can sometimes cause fewer fronts to make it into Florida. We could have extended periods where we don't have any fronts moving into the area, and that's typically what keeps temperatures above normal for longer periods during a typical La Nina. So La Nina sets the stage, but it's not a direct cause of, for example, a drier than normal winter or a warmer than normal winter or any specific weather patterns that occur during this winter or during the dry season. It's not directly caused by La Nina, but La Nina helps set the stage for those individual weather events to occur. But we also have other patterns that occur at shorter time frames that can influence or even dominate for periods of time. Even during what could be a prevailing La Nina, there could be periods during that time, during the winter, for example, where oscillations such as the North Atlantic Oscillation, the Arctic Oscillation, and others that can actually modify or change the pattern on a temporary basis. So that's the La Nina side of it. So the other things that we look at are, again, as I mentioned before, we look at trends. What have the past 10 or 15 years been? And from a temperature standpoint, we've certainly been above, each of the last 11 winters have been above normal. So when we factor in the typical influence of La Nina along with the trend or the last 10 years of temperatures, that definitely leans us on the warm side. When it comes to temperatures, what we would typically experience during a La Nina, again, combined with what we've seen the last 10 to 11 years. Now, the one thing I did, I looked at, since this is a third year La Nina, which is a rare event, I looked back at the previous two, the last two third year La Nina events, and see what patterns or what happened during those 2 years, during those two periods. And actually, those periods were characterized by below normal temperatures across the southeast U.S. and Florida. So the opposite of what the longer term La Nina conditions would typically reflect. But, when we look at this, we have to remember 2 years or two episodes, in this case, is not enough to establish a definitive trend. So we can't say, I would caution to not use this and say, okay, well, this third year La Nina is a little bit special. Maybe it's going to be totally different. Or maybe, in other words, instead of being above normal like it would typically be during La Nina, we're going to be below normal just because those previous two third year episodes were below normal. I think, we want to caution to not use that because 2 years is not enough to establish a definitive trend. Okay, so from a precipitation standpoint, again, for precipitation, for trends, we go back to 15 years. So combining the typical La Nina pattern with trends, that does lean us certainly in the direction of drier than normal conditions for this winter season. Again, La Nina pattern plus the past 15 years. So I did the same thing. I looked back at the previous two third-year La Nina events, and it did indicate drier than normal conditions, or those previous two had drier than normal conditions. But again, 2 years is not enough to establish a definitive trend, although this particular trend here, or this particular what occurred in those previous two third-year events, does generally match up with the average La Nina pattern. But again, or certainly we don't want to hang our hat, if you will, on what happened in those previous two third-year events. So again, as I mentioned, typically there's less storminess or less severe weather events or fewer severe weather events during La Nina winters, and this slide illustrates that. We compare the tornado frequency during La Nina winters compared to what we would see during a strong El Nino winter. There's a pretty big difference. In fact, it's the frequency is more than double during El Nino dry seasons for tornadoes in South Florida versus a La Nina pattern, which is what we're in now. And so then the third factor is what are the computer models showing? In other words, what are they projecting for the next several months? And it's pretty consistent. They're all showing pretty much above normal temperatures. So the map on the left is the consensus of all those long-range models, showing those red colors across Florida, indicating above normal temperatures is what we'll more likely than not experience, with probabilities in the 70 to 80% range. And these probabilities are a little bit lower than last year's winter outlook, but they're still certainly above 50%. For precipitation, again, these models are consistent with the typical La Nina pattern, showing drier than normal, or the likelihood of drier than normal conditions setting in for this winter, and again, persisting through the duration of the dry season. Okay, so again, when we show these outlooks, I always caution that the outlooks show the most likely outcome, but it's not the only possible outcome, right? So we have, there's three possible outcomes. There's above normal, for example, for precipitation here, we have below normal, near normal, and above normal. So if you look at the probabilities of below normal, they're in the 40 to 50% range. So it's certainly not 100%. In fact, it's not even well above 50%. So there is a chance of any of the other two, near normal or above normal, occurring, but those are lower than the probabilities of below normal. So again, we have to consider that these long-term outlooks are not meant to be taken, or say, okay, the outlook is for below normal precipitation. That's exactly what's going to happen. There is a chance, maybe not a high chance, but there is a chance that we could end up being somewhere, or that it could end up being something different. It could be near normal or even above normal. And sometimes what can happen is we have other intraseasonal cycles, such as the Arctic oscillation or the North Atlantic oscillation. Again, these are oscillations or cycles in the atmosphere that occur as shorter time frames, but can, at least for short periods of time, influence the weather or even override the longer term ENSO cycle. So we've seen some examples of that in December of 2010 during a strong La Nina event, when you would expect La Nina would typically lead to warmer than normal temperatures. Actually, December 2010 ended up being the coldest on record for Florida, and that's because we had a strong negative phase of the North Atlantic oscillation, which favors cold air coming deep into the southern United States. So we had a shorter duration cycle that overrode, temporarily at least, the longer term ENSO cycle. Something similar happened in 1975-1976 winter, which was a third year La Nina, and which was cooler than normal, but that was driven primarily by the strong phase of the North Atlantic and Arctic oscillations. So this shows how these periodic modulation of pressure patterns, this North Atlantic oscillation, again, a shorter time frame oscillation, can temporarily change or modify what the larger scale La Nina could cause. So there you see in 2017, 2018, we had a reinforcement of the La Nina pattern, causing warmer than normal temperatures. But then in 2008, 2009, we had a very strongly negative North Atlantic oscillation, which overrode the larger scale La Nina pattern and actually caused cooler than normal temperatures across Florida. So these shorter time frame oscillations do have a big impact on winter temperatures, especially here in the southeast U.S. and in Florida. All right, so then putting all this together and downscaling it to South Florida, we're going to call for another winter of above normal temperatures, or at least that's what's more likely to happen, with a probable range of 1 to 3 degrees above normal on average. Then for precipitation, of course, below normal. I put a probable range relative to the normal precipitation of 65 to 95%. Now, so the upper end of that's actually close to normal, and that's because we've started out above normal. So the first full month of the dry season, the month of November, as I mentioned earlier, we've had above normal rainfall over a good part of southeast Florida. But we do feel, especially once we get to the second half of the dry season, with the La Nina pattern should pretty much set in, and that should lead to those more typical La Nina below normal precipitation patterns. For storminess, I indicate near normal because for storminess or severe weather, I also factor in flood events, and we've actually already had a couple of flood events in southeast Florida with these stalled fronts in November. And with La Nina patterns, you can have fronts that can stall over the area. So you can have, prevailing dry conditions, and then you have these fronts stall over the area, give us, quick 3, 4, or 5 inches of rain in a couple of days, and that could actually skew your rainfall towards normal, even in a prevailing below normal type of pattern. So that's why the range is fairly large, from 65% of normal, or quite a bit below normal, to maybe something that's closer to normal once we for the balance of the dry season. So the relative lack of precipitation that's in the outlook also means that we do expect, or at least it's likely, that we'll have drought development, especially once we get into February. That's the more likely time frame where we could potentially start getting into drought conditions. Again, we'll see how it actually shakes out, but right now the possibilities are that when we get deeper into the dry season, that's when the drought development could start to occur. And then finally, with the temperatures, even though we're calling for above normal temperatures, we can still have 1 or 2 events in which again, we have these breaks in the pattern where cold air can actually come all the way down to the southeast western Florida. So with that, we could get freezes. We had that last year, actually, in this last winter, January of 2022. We had a pretty strong cold air outbreak that came down into Florida. We had temperatures in the low to mid 20s around areas west of Lake Okeechobee. Actually, that was some of the coldest temperatures they had in that area in a decade. It was still an above normal temperature winter, but we had 1 or 2 shots of pretty cold air. So we still have to, keep that in mind. These brief but intense cold air outbreaks can still occur even in a above normal or even in a warmer than normal winter. So the confidence in general is, I would say, moderate to high. It's not, far from being a slam dunk, but I think especially with the precipitation, we tend to have a little bit higher confidence in the precipitation patterns, maybe a little less confidence in the temperatures. But again, overall, moderate to high confidence. So again, these outlooks are just that. The outlook means it's a general big picture view of a set of conditions that will probably exist in the future. That's the definition from Merriam-Webster. And these outlooks are associated, of course, with a large degree of uncertainty when it comes to specifics. So, if somebody were to ask me, how much rain do you think is going to fall in West Palm Beach this winter? Well, that's pretty hard to pin down, for a specific area, regarding to a specific, variable like a rainfall amounts or temperatures. So we tend to be broader and more general with these outlooks. So again, these are average conditions, what we're expecting. What we're indicating it's not representative of what's expected every single day. And we can have these week to week or even month to month variations from the normal, which, I've mentioned here already before. So at the end of the day, these are useful for general planning and overall awareness, keeping in mind, again, the limitations and the skill that we have when we're doing these long range outlooks. So just to wrap up here, we talked about the possibility of drought conditions. Then with that, there's a higher threat of higher threat of wildfires, especially in the second half of the dry season. So again, these are just general time frames where we can expect, or when we could experience, I should say, some of these conditions. So with that, I'm going to pass it off to Akin, and he's going to talk about the hydrology side, how the outlook will or could affect the hydrology and the water levels, and then after that, we will take questions and answers, or we'll take some questions and hopefully we'll be able to answer them. So now I'll pass it over to Akin.
All right. Thank you, Robert. Good morning. My name is Akin Owoshino. I'm the head of the Hydrology and Hydraulics Bureau at the South Florida Water Management District, and I'll be providing you a summary of the system conditions, how our system has dealt with the rainy season to date, and how we are set up looking into the dry season. Slides up, please. Next slide. So, next slide, please. So first of all, I know several of you probably know about the water management districts, but I'll take the next few slides to describe who we are and what we do. We're the oldest and the largest of 5 water management districts in Florida. We cover an area, 16-county area, stretching from Orlando to the north all the way down to the Keys. We serve a fairly large population, and we've been in existence since 1949. Next slide. I should do that. Okay. The district covers an area of 18,000 square miles, 16 counties, as we mentioned, and we have a mission to safeguard the water resources of South Florida and its ecosystems, provide flood protection for the people we serve, and meet the region's water supply needs. We manage a very extensive water management system called the CNSF system, Central and Southern Florida Project. That system includes more than 2,000 miles of canals, over 2,000 miles of levees and berms that help manage where the water flows. It includes extensive number of drainage basins, several water control structures that help us move, store, or relocate water as necessary, several pump stations to lift water because of the flat terrain in Florida, and acres of area that we use for treating water before we put it into the natural system. We also have Lake Okeechobee, which is the central beating heart of Florida. It's one of the largest lakes in the country, the largest in Florida by far, and I think within the top 10 in the US as a whole. We also have a large and extensive water conservation area that is the Central Everglades. So even though Robert mentioned this, I'm going to go through a number of slides that describe the season just past and allows us to set up for how the system has responded. What this figure is showing you is the summary rainfall across the entire district over the last several months, starting from November of 2021 up till date. What the bar indicates is essentially how much rain was received across our system. And when you see the deeper blues, it means we received rain in excess of the historic average for that month. And when you see the reds, it means we had rain that was lower than the historic average. And the numbers in the red or deep blue area indicates the deficit or the excess of rainfall we got. As Robert mentioned earlier, the last wet season was an interesting wet season. We started really wet in June, and then it got dry, and really, really dry through the beginning of September. And then with Ian in September, that flipped everything around. We ended up with about 6 inches extra over what we typically get in the month of September, this September. And then October, the technical start of our dry season, was dry. And then November, with Nicole and some of the other rainfall we got, has again been wetter than average. So the first figure that I showed you essentially indicated the overall average, but it matters where the rain fell when you're looking at how our system is responding. So these sets of figures show you where the rain fell. The figure to your left, I guess that will be, indicates what you had for the month of September. And then the one to your right shows you what you would have for the entire wet season that started May 13th for us and ended in September. Bottom line is the month of September was exceedingly wet, as was seen in the summary for the entire district. And most of that rain fell in the upper part of the system, in the Kissimmee system, where we saw significant flooding and had to deal with a major event following Ian. We also had really wet conditions in the rest of the system, including on the west coast and the central parts of the system, and the least wet of the system was in the southern part of the district. Looking at the entire wet season, we ended up with a wet season that was just a little bit higher than average. It was about 15% more rain than we would have in a typical wet season, and that equivalent about just a little bit over 5 inches of surplus. Again, that was distributed fairly evenly across the entire district, ranging from just a little bit over 100% of normal to a little bit over 125% of normal, which is 25% more than what we'll typically have. And the area around this southwest coast, Lee County and Collier County, ended up seeing the highest surplus rainfall this wet season. Starting with October, which was the first of the dry season, I thought I'd show you what the rainfall distribution has looked like. The northern part of the system that got the most rain, thankfully or fortunately, was the driest in the month of October. And the rest of the system also was well below normal. We ended up with a deficit of about 2 inches across the system in October, half of the traditional or normal rainfall we get in the months of October. When you look at the month of November, however, it's been wet, much wetter again than normal. We ended up with a surplus. We're in about the 75th percentile, over 75% more rain that we typically get in a November. And some of that was attributed to Nicole, but we essentially just had a fairly wet November across most of the district. Again, most of this was in the track of Nicole and to the northern part of the district. So that's essentially told you what we got in our rainfall-driven system. The system responds to that rainfall, and over the next few slides, I'll walk you through, starting from the north of the district, how the system has responded and how we are staged going into the dry season. For those of you who've seen this plot before, I'd like to explain the red line on that graph. It's what's called an operation schedule. Essentially, it's a guideline for operating the lakes. It's not a template we must follow, but essentially it gives us the guiding strategy for operation of the major water bodies within our system. In the upper part of the system, the red lines have a particular shape that I'll spend a minute describing. What you'll see is that its highest point, what we call the winter pool elevation, is in the dry season, and its lowest point is somewhere in the rainy season. And the way I want you to think about that is that as we manage the lakes, we're trying to manage the water level in the lakes so that they are at their highest as we enter the dry season, ensuring that we have water within the lake to meet the system's needs through the dry season, and that they are low when we're in the wet season, leaving room or capacity within the lake to deal with the rainfall that typically happens and the resulting stormwater during the wet season. The lines in green and blue show how the lake actually responded relative to the schedule. And the key highlight for these lakes in the northern part of our system is if you look in the area around September, what you would see is that when Ian came along, we were kind of tracking close to where we wanted to be on schedule in a number of the lakes, and then we had that big jump. That was directly in response to the rainfall from Ian, and our task went from managing a slow ascent to actually moving water through the system to relieve flooding in those parts of the system and bring the lakes back to their winter pool elevation. We've successfully done that, and these lakes are set up nicely going into the dry season. This is a lake that's not quite that far to the north. This is Lake Histopoga. It's to the west of Lake Okeechobee, a little bit north and west of Lake Okeechobee. And what we saw here, we didn't see as much of a peak, but we saw that response also during Ian. And again, we're managing this lake really close to the schedule, so we feel that this is in a good place going into the dry season. The central beating heart of our water system is Lake Okeechobee, as I mentioned. And this is a very busy graphic. Good news is it used to be busier. I took out some slides. And even better news is I'll explain what these lines mean over the next few slides. So just take a look at this. It shows you how the lake has responded in several select years. I'll pick on this first one, and I added this slide late when I realized when we're going to be having this presentation, because I wanted to pass two key messages. The pale blue line on this graphic represents the current year, 2022. And you see it's not at the end of the year yet. We have data all the way through November, just about to the December 1 starting line. And what it shows is the current lake levels used to be low in early September, and it's risen as the water level, or the water from Ian has made its way into the lake. I show this graphic, though, because if you look at 2020, which is the gray lines in there, we started 2020, January of 2020, also high, over 16, and we ended up over the next period of 24 months, going from a high water level to the lake receding into some really low water levels that got us really concerned, floating with low levels within the lake in, I think, June of 2001. But eventually, we came out of it following some tropical events in 2001. So this is not atypical for the lake, and this is not something that we haven't seen within our system. We've managed the lake under these conditions before. Our water managers have experience managing the lake under these conditions. But it's important to know that even though we have plans and schedules, nature kind of does what it needs to do, and we manage the system with some tools, hopefully to make sure that we're a little bit proactive and ahead of what the system might throw at us. These were some of the other tracks that I'd hoped to share with you earlier when we're initially putting this presentation together. And for this, I'm showing 3 years. And part of the reason why I do multiple years is because our system has some memory. And you want to see how it transitions from one condition into the other. We started 2006, for example, at just below 16 feet and went through a typical dry season where the water levels went down, and by the end of May, which is typically the end of the dry season or the start of the wet season, we had seen a lake recede. But instead of the lake rebounding immediately, we ended up with a drier than normal wet season, and the lake continued to stay in the low end and never rose very much as we exited the wet season in 2006. Resulted in the 2007 year going into the 2007 year with a low clay level, and ended up showing the lowest level ever recorded in Lake Okeechobee sometime that year. Again, we came out of that, and I think it was Faye, the hurricane that did that in September of 2008. But again, that rose the lake rapidly and put it back into preferred ranges going into the dry season for 2008. And this doesn't have any how do I call it, super drama with this particular set of graphics. It just shows a couple of additional years where we've seen how the lake responds. A dry season when things went up, and then a wet season where it stayed flat, and then a typical dry season where things go down, and a poorly behaved wet season where it doesn't jump up quite as much until you get into a tropical system. So we know the system well. We know we could see different things, and we try to use the kind of tools we have to prepare us to be able to manage the lake and the main water system in South Florida with this knowledge and the familiarity with these operations. The last of these tracks that I'll show you is for the last 5 years. And so in the space of the last 5 years, we've had really high conditions, higher than what we have today, when we had, I think, 2017 with Hurricane Irma. We've had lower conditions than what we had today. I think last year at this time, we were almost a foot lower than current water levels, about just a fraction of a foot. But we've had periods when we've been even lower than that. We take a look at all of this. We are aware of the memory in the system, and we have a team that includes water managers, engineers, meteorologists that bring together what we know about our system and the tools that are available, similar to some that Robert shared with you all, to essentially make projections on where the system might be. One of the type of tools, you've heard Robert talk about La Nina and what it might do to the expectations for precipitation and temperature. We're focused now on precipitation mostly. And why do we care? Why do we want to consider the possibility of La Nina? One of the things we've found is that typically during La Nina years, and we look at those years and look at how the systems responded and flow into the lake, what we've typically seen is that we have slightly lower than normal precipitation in La Nina years. So if we have a dry winter, we want to make sure that going into that dry winter, we have sufficient water level in our different lake systems to be able to last through the entire dry season. And so we kind of pay attention to what part of the system we're in. We take a look at other teleconnections, and we factor them all into decision making about how we operate the system through the dry season. Moving on further south, we also look at the water conservation areas. And similar to what we have in the rest of the system, we got enough water in the system. We're at or above schedule within this part of the system, and essentially they're set up nicely going into a dry season. One of the other kind of tools that we typically use, other than the looking at the teleconnections, is we look at projections, short, medium and long-term projections, extended projections from different sources. Meteorologists create this set of graphics, for example, which are quantitative precipitation forecasts that look out 7 days. And what they do is they indicate how much rainfall we might get in different parts of our system and how much confidence we have in those projections. It's critical to know where the rain is likely to fall and how much if we're to know how we should operate. Because having a particular amount of rainfall in one particular area might dictate a particular course of action, while the same type of rainfall in another area might require a completely different course of action. So this is an important piece we have, and this is often served on our website. We take a look at that every week, going into the week. But in addition to that, we also look at products from the Climate Prediction Center, such as its long-term forecasts. And we use this to get a feel for where several months out the system may be going, so that we can be in front of it, we can be ahead of it, and proactively take action to make sure that we are managing the system sufficiently to minimize undesirable outcomes in our entire water system or the area that we support. And so as we transition from the state of the system now into looking out into the dry season, we change our operational strategy or the footing we're on in some ways. Obviously, we keep an eye on the system, we manage it responsively, and we prepare our assets going forward. And some of the kind of things we do is we take this opportunity of the reduced rainfall to check some of our forward pumps, the pumps that help move water in different places that we may need to press into action in the dry season. We test them, make sure they're operating properly. We schedule maintenance. We do proactive or predictive maintenance on much of our system, and the dry season gives us the opportunity to actually implement those maintenance operations and planned upgrades to the system. We switch our strategy from a flood control to more of a conserving strategy by taking specific actions, such as taking a look at our canal levels and moving them to the high level. And we do that because by going to the high level in the dry season, we maintain a slightly higher water table, which reduces the need for irrigation and pumping. But also, by having a slightly higher water table, you increase your gradient towards the Atlantic Ocean on the east coast or the Gulf on the west coast. And by taking that type of action, you are managing or mitigating the risk of saltwater intrusion, which could be extremely damaging if they intrude all the way to our water supply wells that serve most of South Florida. We track rainfall accumulation and projections so that we know that we are managing the system properly and operating in a proactive manner. And we essentially have a strategy to manage available water to last through the entire dry season while satisfying the system's needs. People's drinking water, irrigation, environmental deliveries in the dry periods of the dry season, and so on. But overall, I'm not sure if I'll say we're lucky that it got wet at the end of our wet season. We have our system set up nicely. Most of our lakes are in where we'd like them to be, at their schedule or close to winter pool elevation, and so we're set up beautifully for this coming dry season. I'll bring Robert back, and then we'll be able to take questions from you.
All right, thank you, Akeem. All right, so yeah, as Akeem said, yeah, we'll be happy to take any questions. You can either use your device's microphone to ask it, or you can use the chat feature to ask a question, and we're monitoring it here as well. So, yeah, so we can open the floor for any questions. Okay, just want to make sure the audio is on. Okay, well, there's a question coming in here. Is there any connection between a triple dip La Nina or a third year La Nina and climate change? I have not seen anything that indicates that there is a direct or at least even a correlation between these multiple year or third year La Nina events and climate change. I mean, since we've only been tracking the ENSO phases consistently, or at least in the same manner, since 1950. So that's as far back as we can go using the current method that we use to analyze the state of this ENSO. So since 1950, we've only had two of these. Well, there have been two previous ones. So this will be the third one. So they are low frequency events, and since it's a low frequency event, it's really difficult to make any correlation with anything else that's happening, such as climate change or any other type of whether it's climate change or some other type of naturally occurring cycle in the atmosphere. All right, thank you for that question. Any other questions, either type them in or you can use your microphone to ask the question.
Hey, good morning, Robert. Jesse Spiro, Miami-Dade.
Yes, hi, good morning, Jesse.
Yes, question for you. You made a comment about these winters being warmer than average or warmer than normal, and we've had 12 straight years of above average winter temperatures. When does that become the normal temperature for this time of year?
Well, the normals are based. Actually, it's a good question. It's a good opportunity to remind people of what we consider normal. So normal is the average temperature or rainfall over a 30-year period. So every 10 years, we recalculate the normals for that previous 30-year period. So the current period that we're using for the normals is 1991 to 2020. So they're shifted again every 10 years. We do a recalculation of the normals. So the current normals will at least capture some of the warming signals, for example, the signals for higher temperatures, but it may not capture all of it. So in 2030, we'll do the next round, or we do the next recalculation, which will be from 2001 to 2030. So at that point, assuming that temperatures will continue to increase, again, we're making an assumption, then that next 30-year period cycle that we're going to be using will show higher temperatures. So, but it's always, again, these normals are supposed to be a representation, or supposed to at least capture some of the current trends, but it may not capture it entirely, especially if conditions are occurring, we're having shorter term changes that are occurring. And, so if you divide that 30-year period, let's say if you divide it up only, let's say the last 15 years, the 15-year normals have actually, the temperatures have been higher than the 30-year. And again, and that's a reflection of what you mentioned, these last 11 winters that have been warmer than normal. I hope that answers your question. I know it's a little bit complex to relate it to the 30-year normals.
No, excellent. I appreciate that, Robert. And that also reflects how the changes we've seen with the hurricane increases with the frequency and intensity as well. So usually this time of year, we see at least a couple of days in which we've had pumpkin spice lattes and the fur boots. We haven't seen any of those days yet. So
not yet. But we'll probably get a few of those that coming up. Maybe in the next few weeks. So, thank you, Jesse. Appreciate the question.
Another question in the chat.
Okay. Yes, we have another question. Keen, this is for you.
Yeah.
So go ahead if you want to go ahead and take this.
So again, thanks for the question. This is another good question. The question was, I mentioned earlier that we're set up nicely for the dry season. And the question was, is there still a chance of drought? And the answer to that question is yes. When I mentioned we were set up, I was talking about the water that we had in storage and water that will be available to press towards the various needs we have, including some that will be higher during a drought. So the lakes are at their schedule, are relatively full. Some of our water bodies that we keep an eye on are levels where we'd like to see them going into a dry season. And that's what I meant by the setup. But what actually happens, what nature will do regards the drought will still happen if it's going to happen. And part of the, I think Robert's presentation was that there was some kind of a risk of a drought still, maybe towards the tail end of a dry season.
Mm-hmm. Yeah, and and to add on to that, just a little bit. Typically, again, in an average dry season, I'd say we more often than not will end up in at least a moderate drought towards the second half of the dry season. So certainly the fact that there's at least an enhanced probability of drought conditions in the second half of the dry season is not really unusual. What the higher water levels now will probably do is delay, or potentially at least delay, any onset of those really dry conditions, or at least the water levels decreasing to levels where we would consider them to be in drought conditions. So even if we do, as we think will happen, we'll end up seeing longer dry periods here coming up fairly soon. The water levels are going to have to come down quite a bit for us to start to get more concerned about drought. So if that does happen, it should more likely than not will be during the second half of the dry season. All right, thanks again for the question. Any other questions? Type them in, or you can ask them using your microphone. All right, so far I think, all right. So we'll give one last opportunity for any questions. I want to thank again Keen. I want to thank our partners here at the South Florida Water Management District once again for collaborating here on this dry season outlook. And of course, we do this also for the wet season outlook, which we'll do in May. And also for the opportunity to have us here at their Emergency Operations Center. So again, I want to make sure I acknowledge them before we wrap up here. And we do have one more question. What's the stretch again for the abnormally warm winters? I think that's in reference to how many winters we've had above normal. We've had 11 winters of above normal temperatures for that winter period. I think the last winter in which we had below normal temperatures on average for that entire winter was 2010, 2011. So it's been over a decade now. So I think that's what the question referred to. So hopefully I answered it correctly. All right, so one last opportunity for questions. I know we ran over a few minutes, so I apologize for that, but not too bad. All right, you can reach me via email. I know I sent out the invitation for this Outlook So if you have any questions you want to ask after the fact, or maybe you didn't think of it, but you thought of it afterwards, feel free to contact me. And, if it's something related to something more in Akeen's wheelhouse, I'll make sure to, reach out to Akeen, and we'll get that answer to you. So again, thank you very much for attending, for participating in the Dry Season Outlook, and have a very nice day.